could be older than you, like years older? Well, yes, because according to Einstein's theory of special relativity, time can tick slower or faster depending on your motion and position from gravity.
What? Okay, we'll get back to that. But first, I'm going to teach you all about special relativity. Don't worry, there are only two postulates. One is that the laws of physics are the same in all inertial frames of reference. Inertial meaning not moving or moving at constant velocity. In simple words, you're not accelerating, because if you do, then special relativity no longer applies. For example, if you're on a plane cruising at 700 kilometers per hour and drop the ball pin, it will fall straight down, just as it would if you're stationary on the ground. Note that special relativity no longer applies when you're accelerating. The second postulate is that the vacuum speed of light is the same for all observers, approximately 300,000 kilometers per second. That means that if someone pointed a flashlight on you, he or she will measure the light at 300 kilometers per second, and you'll measure the light to be going at 300 kilometers per second too. Given those two postulates, extraordinary spooky phenomenon derived from them like length contraction, time dilation, and other weird stuff in physics that are real. One such thing is that time can tick slower or faster depending on your motion and position from gravity. We call this time dilation. So here's how it works. If I send my twin to the outer space together with her clock, Allyssa, and she traveled close to the speed of light, and I'm here stationary on the Earth, also together with my clock. Let's look at mine first. Each time light makes a round trip in my clock, I count by 1. At the same time, Allyssa will measure the same rate on her own clock. Now things get weird when I watch Alyssa's clock. Because of her sideways motion, I see that her light has to travel a longer distance for 1 tick. So since light has to travel a longer distance and the speed of light is constant, Alyssa's round trip ticks must take more time. So that means the time actually ticks slower on her, according to me, stationary on Earth. But wait, how about from Alyssa's perspective? So now, from my twin's perspective, I am the one who's moving. Therefore, my clock must be running slower according to my twin. And because according to the first postulate that I've said earlier, that the laws of physics are the same for everyone's perspective, Allyssa and mine, each of us is correct in saying that the other's clock is running slower. So this is where the twin paradox starts. If I stay here on Earth, and Allyssa traveled close to the speed of light to the outer space, turns around and comes back, her whole trip takes 40 years, but I see my twin's clock tick slower. So due to time dilation, Allyssa aged 32 years, 8 years less than me, from my perspective. But for Alyssa's perspective, she was the one who's stationary, and I'm the one who moved away and came back. I'm the one moving close to the speed of light. So my twin should see my clock going slower and should think that I'm the one who aged 32 years at the end of the trip. So that means that when Allyssa gets back, she's either younger or older than me. But wait, how do we solve this paradox? Let's get back to the situation. When Allyssa turns around, she has to accelerate, which means she is no longer in the inertial reference frame. And so, special relativity no longer applies to her. And because of this, when my twin accelerates, I can tell the difference between the physics that might happen with me and her. Allyssa will feel the acceleration during the turnaround, and I will not. So when Allyssa gets back, she will agree with me that I am years older than her.
I'm back!